So if you remember back to chapter 1, we talked about how to graph a function, right? And we talked about how we could have vertical shifts, horizontal shifts, and vertical compression and horizontal stretching. We could also reflect about the x-axis and reflect about the y-axis. So we're going to need to remember all of these um, function transformation rules because they also work for trigonometric functions. They're a function, so they're going to be able to follow all of this same transformation rules. So why don't we practice graphing a few functions, finding their amplitude and their periods. So let's say I want to graph y equals 3 sine of x using transformations. This is not our sine graph, this is our cosine. I need to fix that, but cosine looks like sine is what I'm graphing in orange, right? Here's our sine graph, sorry about that. So what I'm doing here is I'm graphing y equals 3 sine of x. This is an example of a vertical stretch. So what I'm doing is I'm taking every output of sine of x and multiplying it by 3. So sine of 0 is 0. Sine of 0 degrees theta is 0. But if we multiply that by 3, I still have 0. If I want to know 3 sine of pi over 2, well, that's going to be 3 times 1, which is 3. So at pi over 2, I've got 3. 1, 2, 3, negative 1, negative 2, negative 3. Sine of pi is 0. So I have 3 times 0, which again is 0. 3 times sine of 3 pi over 2, well, 3 pi over 2 is negative 1, so 3 times negative 1 is negative 3, right? I'm multiplying all the y outputs by 3. Oops. And then lastly, if I take 3 sine of 2 pi, well, 2 pi is the same as 0 degrees, so that's 3 times 0, which is 0. So here's my new sine graph of y equals 3 sine of x, and all I did was vertically stretch that graph by 3. What if I want to graph y equals negative 2 sine of 2x? Okay, so first off, we do have a vertical stretch of 2. But this negative in front right here, that means it's a reflection across the x-axis, and this is using our transformation rules. And this right here, this is going to be a horizontal compression, and it's going to horizontally compress by a fraction factor of 1/2. So first thing I'm going to do is I'm going to graph our normal sine of x. Then we're going to graph in a different color negative sine of x. And then we'll graph the stretch, right? I just want to show us step by step what we're doing. And then we'll graph the compression. So we can see how we've been able to make this sine graph. And you can always check your work by typing this function into Desmos or by plugging into your graphing calculator, but I really want you to kind of visualize what's happening here. So the first thing in orange, we're going to graph sine of x. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 2. Woo, 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 woo. Next, what we're going to do is we're going to go ahead and reflect that graph across the x-axis. So 0 doesn't move, 1 becomes negative 1, 0 doesn't move, negative 1 becomes 1, and 0 doesn't move. So here's our sine of theta reflected across the x-axis. Next, what we need to do is we need to stretch our graphed by a factor of 2. So 0 stays the same, -1 becomes -2, 0 stays the same, 1 becomes 2, and 0 stays the same. So here's our new function. But next what we're going to do, our last step, last but not least, is we're going to horizontally compress it. So that means we're going to kind of divide our period, the area in which this repeated, in half. So I'm going to take all of this that happens over 2 pi and squish it into just happening up until pi. So let's label like pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Let's label some more points. So now everything moves over a half. So pi over 2, that's where that point is, times a half is pi over 4. So this is going to move here. Oh, wait, no, it's not because we're moving the green graph because the green graph is our latest one. So this is going to move over here. Oop, back to blue. Then what was happening at pi is going to move to pi over 2. So our green 0 is going to move there. This 0 stayed the same, by the way. Next, what was happening at 3 pi over 2, multiply that by a half, right? You get 3 pi over 4, so this is going to move over here, and then 2 pi moves to pi. So here's my new graph, right? We compressed what was happening over 2 pi into 1 pi, and remember that our graph does repeat itself, right? It's periodic, it repeats itself, so now it repeats twice. So that's the graph y equals -2 sine of 2x.